All right, why don't we get started? It's 7 o'clock. Thank you for being here. If you would go down into the chat and just type your name, that worked very well for me as far as taking.
I'm sorry? You can't hear my class, can you?
I
was just making sure because I don't have my headphones with me and I have a class.
So go ahead down into the chat and type your name, okay?
All right, thank you. I'm just waiting. I got locked out of my apartment, so I'm waiting to get in there. Okay.
So and my fingers aren't working. Type your name for attendance. Good. That worked very well for me. Well, it's only us four here, but you know, I'm glad you're here. You'll get the material. Let me just take a moment to go through the D2L class and show you what, you know, where we are. And then I also do have a lecture for tonight, which is not exactly this, it's not the exact same. I'm not going to make you sit through the lectures that you've already sat through on your videos, but just to kind of reinforce some information and then also to get you prepared for the test that we are eventually having. So what I'm going to do is share my screen. I wish I knew if there was a way to move this bar. This bar always goes right above my tabs. All right, are you seeing my D2L screen? Yeah? Yes. Okay, good. I'm going to close all that up. So here we are. And if you don't mind, every so often people are going to request to come into the classroom. So since I don't have a co-host, I'm going to have to stop every so often and let people into the class. All right, so here we are under content. I want to get rid of that. And under content, if we go to course modules, of course, now we're in week 1. So we're in chapter 1. So we're going to be looking at this girl until we finish chapter 1 and we take our chapter 1 test. So I'm assuming today, either you have already started or you're going to start tonight. If you kind of want to keep on track, I'm assuming that you'll do section 1-2 and section 1-3. You'll download the blank guided notes. Hopefully you find them helpful. You don't have to use them, but you know, they are there for you. And you'll watch the videos. Looking at the dates here, this is today. So section 1-1 and 1-2. And when you get into my math lab, you'll see that this homework is now open and available for you. And I'm expecting that you'll have that done by Thursday. Here's section 1-4 and 1-5. I'm assuming you'd work on that on Thursday and have it done by next Tuesday. So I kind of kept the same schedule that I keep if we were to meet face-to-face, a Tuesday, Thursday schedule. Assigned on Tuesday, due on Thursday. Assigned on Thursday, due the following Tuesday. 2 weeks from today, which is the 15th, you'll see a week from today, hopefully you'll do section 1-6 and 1-7. 2 weeks from Thursday, hopefully you'll do section 1-8. Here are some extra videos if you need extra instruction. And here are your homework assignments. This brings you right into my math lab. And you can see the due dates. Now, if you miss a due date, still do the homework. You'll be marked down when we get into chapter 2, you'll be marked down 2 points per day that it's late. But I'd rather you get a 98 or a 96 than get a 0 and not do the homework. For chapter 1, I'm making all the homework due on the 15th. All right, because people are still figuring out maybe getting new laptops, their Wi-Fi's not working, they're having trouble getting their My Math Lab code, whatever, startup bumps in the road. So for chapter 1, everything's going to be due the day of our test. But once we get into chapter 2, then I'm really going to stick with these assignment dates. Okay, as we get towards the end of chapter 1 here, there's a discussion board question about negative and non-negative numbers. 2 weeks from tonight is the chapter 1 test. And so next week I'll go over what's on the test. Now you will not have had the lectures on all of it yet, but you'll at least be able to know what's on the test. So 2 weeks from tonight, you're going to be in the take the chapter 1 test. What does that mean? That means, see, I don't mind that you have your videos turned off now. That's not a problem for me. Just so you know, Zoom does have a feature. If you don't like having your video on because you don't like looking at yourself, you can hover over your tile, and where there's the 3 dots, you can click on don't mirror myself, and then you don't have to look at yourself. But in 2 weeks when we take the test, you will have to have your camera on. All right, and go ahead and look in the D2L class to see what a test-ready position is. There's nothing on your desk except paper. You can't use a calculator in chapter 1. And that's just a way that I can watch and make sure that, you're not asking your husband or brother or sister for help, or you're not Googling for answers. All right, it's kind of a way to maintain integrity for the test. Let me just say, if you came in late to the class, go ahead and type your name down in the chat. I use the chat log, the chat file that gets created to take attendance. All right, so if you have a question, go ahead and you can type it in the chat section of your screen, or you can just unmute yourself. And I'd be happy to answer any questions before we continue. Someone did have a question about the integrity policy. It is a 3-page policy. It's basically the school's standard on, don't cheat, your work should be your own. We don't write any essay papers, term papers, so, we don't really worry about plagiarism, but we do want to make sure we're not using any apps to solve our problems or anything like that, solve our math problems. But another goal of mine was, I want you to take a picture of each of those 3 pages and use an app on your phone to create a single PDF file and upload to the assignment folder. Why did I want that? Because when you take your test, you're going to be working on paper in front of your, at your desk. And then when you're done with the test, you're going to take pictures and create a single PDF file. And so I want you to have had practice with that. I don't want you for that to not work the night of the test. Okay, any questions? Oh, listen, if you could sign in with your first and last name. You know who you are, but I'm still learning who everyone is. And sometimes, believe it or not, it's hard to tell which is a first name and which is a last name. And so I'm still trying to learn who you are. All right, well, if there are no questions, I do want to get into a little bit of a review lecture of important material. You will see this again on the test in 2 weeks. So give me a minute here. I'm going to switch over to this screen now. All right, I know the writing is small, but I'm going to read it to you, and I actually write very big. So we'll go over some type problems. Do go ahead and unmute yourself and just interrupt me if you have a question, okay? Right here, the question is mathematical statements. So one thing that you will do in algebra is you will practice and get better at going from an English statement to a mathematical expression, or an English sentence to a mathematical equation. And this right here says negative 49 is less than negative 12. Now, they're not asking us to solve it or anything. They just wanted us to write it as math terms. So, negative 49 is less than. They said is less than or equal to, we would have put a little bar underneath there. Negative 49 is less than negative 12. That's your answer. All right, so 15 is greater than or equal to negative 7. 15 is greater than or equal to negative 7. Go ahead and you try to write that as an expression, a mathematical expression. This is English words. You write it in symbols.
So can we write it in the chat box or write it on paper?
If I were you, I would just write it on paper. Maybe what I'll do next time is I'll upload this to D2L so you'll have it before the lecture. I was just pulling some examples, or maybe I'll pull examples actually from the book, and we'll all just bring up the electronic copy of our book. I was trying to think how to best facilitate this lecture here without actually doing video lectures. All right, so this is a 15, that's a 15, is greater than or equal to. Greater than or equal to negative 7.
Greater than.
Greater than or equal to. So for these greater thans or less thans, the arrow always points to the smaller number. If we were to draw a number line and here is 0, can't see that, let me pick something that's darker. If we were to draw our number line, and here's 0, and here's all of our positive numbers, here's negative 12, and somewhere down here is negative 49. The numbers to the left are the smaller numbers. That's why the arrow is pointing to the smaller numbers. Here, if I have a number line with 0, here's my negative 7 on my negative side of 0. Here's my 15 on my positive side of 0. Notice negative 7 is to the left. Negative 7 is smaller. That's why this arrow, that's why this is pointing to the negative 7. Are we good? I'm going to keep moving on. Stop me if you have a question, all right? Because right now I can't see any of you. All I can see is this. Here, the instructions say, tell which set of numbers, tell which set or set the number belongs to. And you've got natural numbers, whole numbers, integers, rationals, irrationals, and real numbers. And we want to know negative 7. So let's just go through this list. The natural numbers start at 1. All right, negative 7 is not in there. It's not a natural number. The whole numbers. The whole numbers look a lot like the natural numbers, except it also includes 0. Well, negative 7 is not going to be in that list either. integers. Integers can be positive or negative, and if they are written as a fraction, the number in the denominator is always 1. So my integers are all the whole numbers, but also the negatives. -1, -2. All right, so -7 actually is an integer. I'll circle that to say, yep, it is in the set of integers. All right, rational numbers. The two things about rational numbers are if they're written as fractions, the numerator and the denominator are integers. So like 1/2 would be considered a rational number because the numerator is an integer and the denominator is an integer. Or -3/4 would be considered a rational expression. Why? Because -3 is an integer and 4 is an integer. And all of your integers will always have 1 as a denominator. So -7 can be written as -7/1. So -7 is a rational number. Now we don't need it for this problem, but the other way to know you have a rational number is if it is written as a decimal, it either repeats or terminates. Okay, so 1/3 would be considered a rational number. When you write that as a decimal, you get 0.33333 and it repeats. That's how we know it's a rational. Or if you write 1/2 as a decimal, you get 0.5 and it doesn't go on and on and on and on, it terminates. So -7 is an integer, but it's also a rational number. Now, numbers are these are mutually exclusive. Either a number is rational or irrational, one or the other. And you don't really have to worry too much about picking up your irrational numbers because they look odd. Like pi, they're Greek letters. E is an irrational number. Or they have odd symbols like the square root of 5. If you were to put the square root of 5 in your calculator, which you're not allowed to do just yet, you'd get a decimal that does not terminate and does not repeat. So -7 definitely is not an irrational number. And then all the numbers we're going to deal with in this class are all real numbers. When you get into 98, there are some things called imaginary numbers, but we won't have that at all in 96. So if you see a question like this on your test, remember that any number we are looking at is considered a real number. Okay? I'm going to keep going. I don't know just how much you want to do on your own now during lecture. You certainly have plenty to do while you watch the videos. So it's not like you're not getting the material. This is kind of your chance to have a review or ask questions, that's for sure. All right, here, going on to the third question here. They want us to insert a less than, a greater than, or an equal to sign between these two, and these are absolute values. The absolute value of -1 and the absolute value of 13. So these long bars are called the absolute value bars. The result of absolute value is always positive. So if I have the absolute value of a positive number, it's going to be positive. If I have the absolute value of a negative number, the answer is positive. The result of taking the absolute value, when you get rid of the absolute value bars, you'll always get a positive answer. Or it could be 0 too, but that doesn't happen too often. So what is the absolute value of -1, since that's negative? The absolute value of -1 is a positive 1. What's the absolute value of -13? Positive 13. And if they want us to put in a greater than or a less than or equal to sign, the arrow always points to the smaller number. 1 is smaller than 13, so I'm going to use the less than sign, which means the absolute value of -1 is less than the absolute value of 13. So that's your correct answer right there. That's the sign you would want to include. Are there any questions? Any questions? All right, we'll keep moving on then. Section 1.4 had to do with, I think it was 1.3, I think had to do with fractions. Multiplying and dividing fractions. Now we like multiplying and dividing fractions because they do not have to have the same denominator. When you add or subtract fractions, they have to have the same denominator, and sometimes that can be a little bit of a pain in the neck getting them to both have the same denominator. But when you multiply and when you divide, they can have different denominators. So this is 5/8 times 5/8. That's the font that was written here. Another way you might see this is when two expressions are right next to each other in parentheses, that means you're multiplying them. That also means 5/8 times 5/8. And not as often, you see this in arithmetic and pre-algebra. You don't see this in algebra much, but it's not that it's incorrect. It's just we don't like using this cross for multiply because in algebra we're going to start having variables and we use x for something different. So this is more of a pre-algebra or an arithmetic type of notation. So you won't be seeing this much. You'll see it this way. It's not incorrect, just not as clear for algebra. All right, so the way you multiply fractions is you just multiply their numerators across and you multiply their denominators across and then reduce. So let's multiply the numerators. 5 times 5 is going to give us a 25 in the numerator. 8 times 8 is 64. And then we look here and say, hey, are they both even? If they're both even, I can reduce by 2. Or can a 3 go into them evenly? No, 3 doesn't go into 25, or 3 doesn't go into 64 either. Can a 4 go into them? You would reduce. 4 can't go into 25. So this is your answer. Okay, why don't you do 1/3 times 12/7? there at your desk. So there are really two ways to do this. The first is to just multiply across. 1 times 12 is 12. 3 times 7 is 21. But before I circle that, I say, hey, you know what? 12 can be divided evenly by 3, and so can 21. 12 divided by 3 is 4. 21 divided by 3 is 7. So in this case, I multiplied first and then reduced my answer. The other way to do it, which is the way I like to do it, but it's purely a preference, is I like to reduce first because then you don't get such big numbers. You look at the different numerators and the different denominators and you say, hey, is there a number that can go evenly into either one of the numerators and denominators? They don't have to be in the same fraction. And I see a 3 here and a 12 here. And I go, this is 3 times 1, and this is 3 times 4. So I'm going to reduce before I multiply. 3 goes into 3, and I'm going to make that a 1. 3 goes into 12 4 times, and I'm going to make that a 4. So now when I multiply across, I have 1 times 4 is 4. And 1 times 7 is 7. Same answer. Multiply and then reduce. Reduce and then multiply. 6 of one, half dozen of another. Just remember your answer has to be in reduced form. So that's how you multiply fractions. You multiply the numerators across and the denominators. Now this question number 5, this is a division problem. I'm going to write it a little bigger because that looks like it's hard to read. 3/8 divided by 9/4. 3/8 divided by 9/4. It's a two-step process to divide fractions. Step 1. Change division to multiplication. Step 2. Use the reciprocal of the second fraction. Reciprocal. What's a reciprocal? The reciprocal of a fraction is when you swap the numerator and denominator. So 3/8 divided by 9/4 has the exact same answer as 3/8, change division to multiplication, and use the reciprocal of the second fraction. It's very important you use the reciprocal of the second fraction, not the first one. So I've changed my division problem into a multiplication problem. And so now I have 3/8 times 4/9. And I think I'm going to reduce first and then multiply it. You're looking for numerator and denominator pairs that can be reduced or have a common denominator. A common factor. Sorry, I used the wrong word, common factor. Here I have a 3 and a 9. This is 3 times 1. This is 3 times 3. So I'm going to take care of this set of numerator and denominator right now. 3 divided by 3 is 1. 9 divided by 3 is 3. And as I look closely here, in this set of numerator and denominators, this is 4 times 1, and this is 4 times 2. So I can also reduce the 4 and the 8. 4 divided by 4 is 1. 8 divided by 4 is 2. And I can't really reduce anything else, so now it's just time to multiply across. 1 times 1 is 1, and 2 times 3 is 6. And that's your answer. So why don't you try this? What is 3/4 divided by 6/12? You try 3/4 divided by 6/12. All right, following my two-step process, this is now going to become 3/4, change the division to multiplication, and use the reciprocal of the second fraction. And now I'm going to reduce here. Here I'm going to pick this numerator and denominator. These are both multiples of 6. 12 divided by 6 is 2. 6 divided by 6 is 1. By the way, you could have picked these two. You could have picked the 3 and the 6. It would still work. All right, and you know what I see here? Here's a 2 and here's a 4. We like even numbers because we know we can always reduce by 2. 2 goes into 2 once. 2 goes into 4 twice. And I have a 3, a 1, a 2, and a 1. No other numerator denominator pair can be reduced. So I'm just going to multiply across. 3 times 1 is 3, and 2 times 1 is 2. And that's your answer. Okay, do you have any questions?
I'm sorry, I didn't catch what you said.
Do you have any questions?
Oh, sorry. No.
All right. Did everyone hear me when I asked when you sign your name in? Can you please put your first name and your last name? Okay. Great. Thank you. Only because, like I said, I'm still kind of getting to know who's in the class. And some of your names, they could be 2 first names or 2 last names. Well, that's all the material I wanted to cover tonight because some people might not even have started section 1, 2, and 1, 3. And that's okay. You're not behind. This is the week where you're going to get started. So next week we'll have another lecture, and look on D2L. I'll try to have the handout available to you so you can print it out before the lecture. And then in 2 weeks you're going to have your test, and that's all we'll do that night. The night where we have tests, the only thing you do is the test. We don't have a lecture also. All right, well, I'm going to stay on. You can hang up. All right, I won't hang up on you. Unless you have a question, you're welcome to just leave the meeting. And I'll see you next week.
Have a nice night.
Bye, thank you. You too.